is actually in our course. Remember how I told you that the number one problem with people reading tape measures or working is little things like fractions. So the first thing we're going to talk about is how to read a tape measure, because a great many people do not know how to read a tape measure. A tape measure is just a number line. Remember how in grade 3, Mrs. Bag Crumble had the number line on the wall? Yeah. 1, 2, 3, 4, 5, 6, 7. Usually up to 100. And then maybe you got to grade 6, and then that wise-ass teacher had another 100 going the other way, and it had negatives, right? And then they started talking about fractions, right? We all know this. It's okay. That's all this is. 1, 2 are the whole numbers. Notice that they have the longest lines. The next longest line is a half. Cool? The next longest line is what? A quarter. And then the next longest line is what? An eighth. So this tape measure... Oh, I didn't do a quarter, sorry. I went to... There's the quarter. The next one is an eighth. And what's the tiniest little one? A 16th. Pink is hard to see on my crappy projector, but I am working on that for you. So every little tick is a 16th. All right? Now I have to remind you all, I hope I don't have to remind you all, how fractions work. Does everybody remember? Yeah? 1/2 equals 2/4 equals 4/8 equals 8/16. We all remember that, yeah? Not going to go over it. Everyone's cool? Great. So you guys need to tell me what these 5 measurements are on this tape measure. All right? Remember that SI doesn't use fractions. Is this SI or is it imperial? Imperial, so it does use fractions. Okay? So everybody take a moment. You can talk to your neighbor. You don't have to do it quietly. Tell me these 5 measurements. Pardon me? Yeah, there are, but we don't commonly use them, so. When you feel you have one of them, you have to tell me what all of these arrows are pointing at, what the measurement is, Antonio. Does anyone care to volunteer the first one? Is anybody still getting out something to write with? Antonio, what do you got? Yep, that is 1/4 of an inch. Remember, the quotation marks is the abbreviation for inches. What's this one? The next one over. Anybody wish to? No, Antonio, you already did it. Somebody else can read a tape measure in here. Mark. 11/16. Absolutely correct. Anyone want to try the third one? I'm going to end up going back to Antonio and Mark anyway, so it doesn't matter. Antonio? 1 3/8 of an inch. Mark, do you want to handle the fourth one? Oh, wait! Cassie wants to handle the fourth one. Hit me, Cassie. 2 13/16. Abso-smurfly correct. Well done. And the fifth one. Fifth. Also fun to say, because an F and then a TH together. Difficult if you have a lisp. Or is it easy because you have a lisp? I don't know. I don't have a lisp. My son has a bit of a lisp. I'm going to go home, make him say fifth and lisp and double check. Sixths is always hard to say. Sixths.
Excuse the interruption to your classes. This is the last announcement for pictures. This is the last call to make sure that you had your photo taken. If you missed it, or if you're a staff member who hasn't had it taken yet, please head on down now. Thank you.
Anybody need to go? I need to go. Here's your job. Finish this ruler and do this ruler. Now this ruler's sneaky. Pay attention to it. What is that measured in and what is that measured in? Dum, dum, dum. Okay.
That was like an evolutional smile.
Uh-oh. Yes, but they don't look like that anymore. They were very young then. I have to get some new ones. So what was the fourth one here? Fifth one? What was the last one up top? This one. Right here. 3 7/16. Now, I left you guys with these 7. But there was a trick, yeah? What is the top one measuring? Centimeters, which means it's SI, which means, do I use decimals or fractions? Which? Why? You do, because SI is done on base 10, right? So this is all going to be decimals. What's this guy going to be? 11 point what? 4. What's this guy going to be? What's this guy going to be? 16.7. And that's it. Everybody cool? Yeah? You have to pay attention here. And I'll tell you why in a second. This ruler down here, is this ruler, first of all, we know it's imperial, so we know we have to use fractions. But is this ruler the same as the tape measure you just practiced on? Annalise says no. What's different about it? It's only got, what is it broken into? It doesn't have 16ths. It only has what? 8ths. So even though it's got one tick, it's not going to be in 16ths, is it? So what is this? Antonio? 4 5/8. Because 4 8/8 would be 5. 7 6 5/8. Got it? What would this one be? Urine. 5.5. Certainly. What about this one? Mark. 6 7/8. And what about this one? 7 1/4. Or, of course, 2/8. Right? Everyone can read a tape measure? Yeah? Excellent. Now, if I'm not mistaken, the next thing in your book should be these weird pincher things. We're skipping those for a while. That should be the next thing in your book. Should be the calipers. We're not going to do them for now. I need you to flip. No. Skip that page too. That's going to be your bit of homework. Skip that page. That's homework. Look on the screen behind me. Go to the screen that has converting units within systems. Yeah, your font is different. Within systems, that means SI to SI or imperial to imperial. You're not moving back and forth. Okay? That's tomorrow's lesson. Everybody cool? All right. So, let us go on with that, cabbages. Now, I am going to print you guys what's called a data booklet. It's got all the equations, all the conversions, everything you need for Math 10 all in one place. But I don't have it printed for you yet. Okay? Today, this page will be more than enough. All right? This is the first part of that. Everybody cool? Okay. So you will notice there's a lot of information that's really important on this page. Okay? Do you have to memorize it? No, because you're going to get this page on all your tests and quizzes anyway. Okay? But you do need to know how to read it. All right? So as you can see, all the equations are there. All the abbreviations are there. Everything's on here that you need. This one's very important. Feet or feet, inches or inches. This one is important. It's a real pain. Right here, a metric ton. This is SI, and it is right there. A metric ton is 1,000 kilograms. But please notice over here, an imperial ton, which we say the exact same way but spell differently, is 2,000 pounds, which is different than 1,000 kilograms. Everybody cool? Again, you don't need to memorize that. You just got to be aware of it. The word ton, when somebody says it weighs a ton, it can mean two totally different things. And the only difference is they're spelt differently, even though we say them the same way. Of course, if we were really French, we would say ton for this one and ton for this one. But we're not French, so we just say ton. Got it? All right. Now, conversions in math class, conversions in physics class, conversions in chemistry class, conversions in biology class, conversions in cooking, conversions in automotive work. All conversions can be done the same way. I'm going to show you that way. There are lots of shorter ways and lots of shortcuts that you can develop for yourself. But I'm going to show you the one way that always works. Then you are welcome to develop your own. Follow me? Most of you can probably already do this. You probably have indeed already done it. When you are converting, I'm still on a highlighter. Convert by using fractions. And here's what it looks like. Here's the formula. You take the measurement and you multiply it by the following fraction. Everybody cool? The fraction is this. Oops. What you want over what you have. And I'm going to show you what I mean right now. Okay? Now, almost all of you are going to look at this and say, oh, there's 100 centimeters in a meter, so that's 4.85 meters. You're going to do that in your head, aren't you? Almost all of you. And if you didn't do it in your head, what I just said will remind you, oh yeah, I can do that in my head. Is everybody with me? I know you can do that in your head. I'm well aware you can do that in your head. I also know that you can add 3 and 5 in your head very quickly. But if I ask you to add 3.27 and 3.759 in your head, it becomes difficult, doesn't it? So even though you can do this in your head, I'm using this very simple example to show you how this more complex method works so you can use it when you need to. You picking up what I'm putting down? Okay, so let's use our conversion method to work this out. What is the measurement that I have that I am starting with? Read the question. What is the measurement that I am starting with? Antonio. I am starting with, yes, 485 centimeters. Now I need to convert that. So I'm going to multiply it by my conversion factor. And that factor is what I want over what I have. Antonio. So 1 meter is what I want, because I want meters. And what I have is 100 centimeters. Everybody cool? Now, this 485, you guys all remember number theory. What is 485 really a numerator for? What would be down here that we don't write because math guys are lazy? What is the denominator in every single number? 1. So this is technically over 1, correct? Now we just do the math. Centimeters, centimeters. I have something that's the same in the numerator and the same in the denominator. So what do I get to do with anything that's the same in both parts of a fraction? Antonio. Pardon? Yeah, they become 1. We cancel them out, right? So now I have 485 times 1, right? So that's 485 over, what's down here? 100. And then, since it's SI, System International, I only have to move the decimal place, don't I? But what if I was doing imperial? Would I just move the decimal place? No, I would need to actually divide, wouldn't I? So what is this answer? 4.85, which we knew in our heads from where we checked. At this point, you're you're either going to be able to do it in your head because you're moving the decimal, or you're going to use your calculator. Is everybody with me? That's an easier one. Let's look at this next one. I'm going to change colors. Yes, Mr. Como. Excellent point. I need a unit here. What was the only thing left over in my canceling? Meters, because that's what we want to bring it to. Everybody good? Now remember, every single conversion in every single class can be done using this method. If you're in physics and you're converting feet to meters, minutes to seconds, you can always use this method, always. And when you get to chemistry and physics in Science 10 and in grade 11, you are going to be doing tons of these conversions. Okay? Now, like I say, yes, Mark? Pardon me? Imperial or oh, tons of these conversions. We're in Canada. Tons. Ton. My French is bad. Yes. Okay. So in this one, we've got yards to feet. So again, if you already know that 3 feet are in a yard, you can do this in your head. But should we do it in our head? We shouldn't. We're going to practice it. So what did we start with? Oh, I went over to 3 instead of 2. Sorry, guys. What do we start with? 15 yards. And then we have to multiply what we want over what we have. What do we want? We want feet. So what goes on the top here? 3 feet. Now we go to our chart. And where do we find feet and yards? Right here, yes? So we are converting to 1 yard on the bottom. Now, what do I get to do? Exactly. 45 feet. Why is it feet? The yards have canceled. 15 times 3 is 45. Is what's on the bottom here? Still a 1. Math guys are lazy. Do we ever write that 1? No. So we have 45 feet. Is everybody cool? You try these two. Number 2, not a problem. Number 4, a little bit more so. I will wait a minute whilst you do that. Abresia. That's feet. So this is 136 feet. 2 yards. And I would love to tell you I knew why we used 1 tick and 2 ticks, but I don't. We also use them in English, and we also use them for minutes and seconds, which is weird. It is confusing. Because in measurement, we divide everything by 10, but in degrees, we divide everything by 360, like time. So. Now notice I've written inches here. Because when I'm doing this work, I want it to be easy for me to do my canceling. I want feet, so it's 1 foot over what I have, 12 inches. The inches cancel, and I'm left with 57 over 12. Now we're in trouble, aren't we? Because is that perfect? No, it isn't. So now, Abresia is doing the smart move. She goes to her calculator. Do it. What's the answer? For 57 over 12. Or you're on the next one? I'm sorry, Abresia. Okay, that's fine. Antonio? 4.75, right? Which Antonio has wisely jumped to the next step. He says it's 4 3/4. Everyone cool with that? Now, here's the problem. Is this a metric or an imperial measurement? SI or imperial? It's imperial, which means, are we really technically allowed to use decimals? No, we're not. So this is 4 3/4 of a foot, yes? But 3/4 is a fraction, and it's this decimal, which is in base 10, isn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do we measure feet and inches in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? No. Feet and inches are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And here is a giant mistake everybody makes when they're converting things. They see 4.75, and they tell me that it's 4 feet, 7 inches. Is that right? No, it isn't. Everybody cool? You have to watch for that. But is 4 3/4 correct? Is 4.75 4 3/4? Okay. What's a quarter of a foot? There's 12 inches in a foot, so what's a quarter of that? 3. And I need 3/4. So that is 4 feet. How many inches? 9 inches. And that is right. Does everybody see that subtle difference? Very often people want to say 4.75 is 4 foot 7 inches. Picking up what I'm putting down? It's going to happen to you in physics class because you're going to be doing time in physics, aren't you? Is time in decimals? Times in decimals? 4.5 of an hour is 4. What is it? What's 4.5 hours? 4.5, which is 4 hours and how many minutes? 30. Seeing the problem? You have to be aware of what you're changing your measurement into. Is everybody cool with that? Does that matter with imperial, SI, or both? What's the only time this comes into play? Is this an imperial thing or an SI thing? It's imperial, because SI, we can leave it as decimals. Why? Everything's in chunks of 10. Centa, deci, regular, deca, hecto, kilo. Right? Okay, so let's go to this next one and see what we got. 136 feet. And what do we have? See you, Mr. Como. Oh, yes. Yes, okay. 136 feet. We are going into yards. So 1 yard over how many feet? 3 feet. What do I get to do with the feet? Cancel, cancel. And I get 136 over 3. Is this what you were working on, Abresia? Oh, you've gone ahead of me, you crazy. 136 divided by 3 is what? 45.3 repeating, isn't it? Yeah. Is that 0.3 repeating allowed? No. What fraction is 0.3 repeating? 1/3. So that's 45 1/3. Is that allowed? We're getting warmer. 45 yards, and then 1/3 of a yard. But if a yard is 3 feet, what's 1/3 of a yard? 1 foot. So it's 45 yards, 1 foot. Everybody understand? Everybody cool? Okay. So you guys, your job right now, your next page probably doesn't look like mine. It's probably not vertical, is it? You do 5 to 10. Go. I'll put the right answers up in a minute.
I don't even know if there's more.
Did you?
I just wanted to see if I did those two right then.
Because you guys had, yeah, your pages. That pisses me off. I don't know why that did that. Yep. Yep.
I was in AW. There's like
Yep. Of course there are. Yep. But I'm thinking in the future. So you guys go up to 10. I'll write the right answers in. shrink that down a little so all of mine will fit on one page. So those are all the right answers up to 10. Check your work. Make sure you're doing it right. Then your assignment today. Mark, may I borrow your book for a moment? Because for some reason, what printed on this new computer does not look like what you guys have. Yeah. We're going to work through up to number 20. And then after number 20, you guys have worksheet 1.2. That's your homework tonight, okay? It's 2 pages later for you. Is everyone okay with this? Everyone's doing it right? Now remember, like I said, you should be starting to see the patterns, yes? For example, 5250 yards to inches times, I want inches, 36 over 1. You don't need to do a bunch of work, do you? You could have looked at that right away and known that that was 5250 times 36. Picking up what I'm putting down? When you're staying within the same unit, it's real easy. You can often skip a step if you're staying within the same system. Okay? Everybody cool? Okay. Can I go away from this page? Please remember, if you don't have it done, this is all being recorded. It's going on YouTube. And you can check your work there. All right? Your next page, you guys should have number 11. 11 to 20. It's the beginning of it. I want to call your attention to I'm going to circle ones that have funky tricks. Keep your eye on number 13, because I guarantee somebody's going to get it wrong tomorrow. Keep your eye on number 18. On number 20, please scribble out the HST. We don't even have that anymore, but I was too lazy to change my notes. Is that even written on your number 20? Number 19, I mean?
Oh.
Or did I take it out on your guys' notes? Good. And this is a typo. Lineal isn't a word. Linear. I know, I'm an idiot. Number 19. Now, guys, let me see your book. Yours says linear? Okay. So I know what happened. I said print to one note, the one that I hadn't corrected. So it's my fault, not anybody else's. All right. Now, you will notice, guys, some of you may not know what crown molding is. And I'm not telling you, because that's what happens in a math class. Sometimes you get a test question that you don't know what it is. Right? But you should be able to figure it out based on how it's sold and the information you have. I want to wait and see how that goes tomorrow. Okay? Now, let me apologize for a couple of things. One, class is over in 10 minutes. And you're only getting 10 minutes to do what looks like a lot of work. But let's remember, we lost 10 minutes to photos. We were all over the place. Normally, I wouldn't leave you at this point. Do you understand what I'm saying? You would have more class time. Okay? So just keep that in mind. Don't think that I'm going to talk for 75 minutes and then say, now do 47 questions. Go! I won't do that normally. Picking up what I'm putting down? Okay. So you guys work on this and worksheet 1.2, which is the next page in your work. Okay? One question on it is very hard to read. It didn't photocopy very well. On the second page, if you can't read it, no big deal. It's the one about florists cutting ribbons. If you can't read it, don't worry about it. Yeah, that's it. You're going to do 1 to 20 right now, and then the first worksheet, worksheet 1-2. You don't have to do the last worksheet that had the puzzles on it. I'm skipping that. Okay? Everybody Gouda? Great. And I'm going to start filling in right answers for 11 to 20. They will be on YouTube. You can check it tonight. Okay? If you wish, to make sure you're doing it right. Everybody with me? Okay. Now notice, please, I'm only putting the right answers on here. Tomorrow, if you wish to know how I got to that answer, I'll show you. Cool? So it's just like in your textbook. You only have the answers in the back. I'm only giving you the answers to mark with. Okay? Okay. Okay, number 17, he's framing a picture. The picture is 3 feet by 5 feet. Where does the picture frame go, Antonio? Where does a frame go on a picture? Do you know the word frame? This is a frame. It goes around the outside. So you got to tell me how many inches of frame he's got to buy to go around that picture. Okay?
So the mold in the perimeter or the mold
Yo. Doesn't matter. I've got both. Have good days. Hey, Emma. I'm great. How are you?
Great. Did you get your picture taken?
I did indeed. And I got my picture taken with Mr. Van B.
Oh, really?
Yep. On his lap.
Wow. Have a good day tomorrow.
You too.
Bye-bye.
Yep.
Do we have to do the worksheet one?
Yes, please.
Thank you.
No problem.
Myers,
Yes.
can I get you to sign this permission form so go on the teapot no trip with the ISP class on Friday?
Oh, you're an ISP?
Yeah.
Okay. Yep, no problem. Thank you. See you. Wait a minute. Janine. Yes. What can I do for you, Janine? Hey, Bryce. Hey, you follow the same rules. What do you want? 17.2 mm times, now, 1 km over, now how many millimeters are in a kilometer? Well, there's 1,000 in a meter, right? And then there's 1,000 meters in a kilometer. So it's 1,000 times 1,000. So it's 1 million. So if I'm dividing by a million, I'm moving the decimal, 1 decimal for every 0, yeah? So I gotta move it 6 spaces. There's 2 of them, so 4 more spaces. What goes in the holes? That's what I mean. See, even when it's stupid, because you would never measure that many millimeters in kilometers, would you? Even when it's stupid, the method still works. That's why I wanted to show you that method. Okay?
And then we have to do up to 20.
And then the worksheet. Yeah.
Okay.
Yeah.
Yeah, so I'm in physics, and most of the math obviously is
Algebra.
but
Yes.
which is what I was good at. But for converting meters squared into anything,
Oh, okay.
was that right? Because I converted it to meters, squared to cubed. But
Okay. So you want? I assume this is supposed to be centimeters cubed.
Nope.
No.
I converted it to meters and then divided to get meters squared instead of cubed. So like divided it by.
So he's going. He wants 100 meters cubed divided into 6.25 centimeters. That question makes no sense to me. Like, I don't understand. Now, I know you're already thinking about squares and cubes. That's what I taught you, right? But I don't know what he's trying to do here. Like, this is just finding a volume, but he's trying to divide. Now, what that says to me, Bryce, and I'm just going to pause my recording here because all right.
Unfortunately, physics teacher doesn't like to teach math the way I like to learn it. All right, thank you.
See you.